Hey guys, good morning. I hope all of you can hear and this is working good. So, so this is the second open masterclass in the series, and today we are going to talk about AWS S3. Let me introduce myself and then I'm going to talk about the agenda that we are going to cover for the day. So guys, my name is Mahendra Pandey. I work as a freelance cloud solutions architect come trainer. I have having more than 18 years of experience. I've been certified in multiple technologies and right now working as AWS authorized instructor and Google GCP authorized instructor. As for the agenda, what we are going to cover as part of this open masterclass is we are going to start with the fundamentals of S3. Then we'll move on and talk about core features. For example, we'll talk about buckets, objects, and various other components which are part of S3 service. Next, we'll move on and talk about security essentials, where I'll talk about the security of the bucket as well as the object. How do we implement it using ACL and bucket policies? The next topic is going to be on cost management. This is where we are going to have a look at how do you reduce the cost, wherein at the same time, making sure that you achieve the performance that you need and efficiently manage your storage. Next topic is going to be on advanced security and monitoring. And we are going to finalize this open master class talking about designing for scalability. What are the important points that you need to consider for when you're designing S3 for applications and where you're looking for scalability? What are the important points you need to keep in mind? So let's get on to it. That's it. As you know, the last masterclass that I've taken, um, it was only about um, the agenda that I had discussed, and also at the same time, there was also I mean, I basically took it up, and instead of going through PPT and slides, I decided that I'm going to go through the actual screen and demos that gives a better understanding rather than just talking about a particular topic theoretically. So let's move on to it and let's have a look. So what I'm going to do is I'm going to log in to the management console. So that's your management console, and what we are going to do next is we are going to get to S3. Let's talk about the basics of S3, and rather than going to S3 directly, why not talk about the basics of storage? And as said, no PPTs, no slides. It's just going to be my blackboard and the explanation for the same. Hey guys, I'm really sorry. I just understood that I didn't had the audio feed for when I was explaining on iPad. Really sorry about that. If you can just give me a moment here. So when you decide things not to go wrong exactly at that time, you miss out. I suppose I'm audible now. Okay. So let me redo this. I'm really sorry about this, those who are going to watch it later. Uh, so what I was talking about is as and when we start about and talk about storage, storage is broadly categorized into three. We have block storage, file storage, and object storage. S3, the topic that we are going to talk about today is object storage. But before we get into object storage, let's talk about what exactly is block storage. Block storage is hard disk drive, solid state drives that you use. All of these are termed as block storage. And to understand it, block storage is any kind of storage where you can perform block operations. Block operation as in sending SCSI commands. For example, a component where I can create a partition or a logical volume. Creating a partition or a logical volume is termed as a block operation, right? Now, different than the block operation is going to be file storage. File storage, we can take an example, NAS, network attached storage, is a good example of file storage. In case of file storage, you may find that you share a folder from server 1 and you try to access that on client machines, right? For example, if there is a Windows server, I may keep a folder shared here, and from my machine, I try to access the folder over here on this machine, the client machine, right? When you do this job, when you are trying to access the shared folder, doesn't matter whether you're using Windows, which uses server message block, SMB, or you're using Unix that uses NFS, that is network file system. Whatever may be the case, if you're sharing a folder and trying to access it on a different machine, client machine, it's a folder that is being shared. Now, from the client machine, you will not be able to perform any block operations. What that means is you cannot send a command from client machine to create a partition in a folder that was shared from the server machine. Now, if we take into consideration that you cannot send the instruction to create a partition or a logical volume to a folder, then what other operations are permitted for you? The only other operation that is going to be permitted, depending on whether you have read write or read only access, you can either create a file or folder inside the shared folder, or you can only read into the client machine. That means you can only access the file and cannot create any content. Now that is file operation which is being performed. File level operation. You cannot perform block level operations. Block level operations like creating partitions on a disk, creating a file system on the created partition or logical volume, that's block operation. When we talk about file, we only perform file operations. That means either creating a folder, a subfolder, or a file inside. This is how you can differentiate between a block and file storage. Now, what about object storage? Is it same? So when we talk about object storage, first we need to understand how an object is managed, how it is created and it's used. It's not the same kind of operation as block and file. Okay, now try and understand it this way. Object storage does not matter whether we are talking about S3 or any other kind of object storage that you may find. But to talk about it in general, object storage uses a flat file storage kind of structure. For example, I have a file. I have a file called file.txt. That's the name of my file. And the content that I'm going to write into the file, what it contains is just 2 words. It contains hello world. That's it. I have my object storage server here. Mind it, I'm still not talking about S3, right? There are other products that you may find in the market that can give you capability to create an object storage server on your own physical or virtual machine, right? So this is my object storage server. As and when I try uploading the file to the object storage server, first of all, what protocol is it using? Is it using NFS protocol? Is it using SMB protocol? Is it using SCSI protocols? SCSI, by the way, those who are not aware can go and look out for SCSI. SCSI. So what kind of protocol it's using to send the data to the server, and what protocol is it going to use to fetch the data? Putting it simple, let's consider what we use is HTTP or HTTPS as the protocol for me to send my file from my machine file.txt onto the object server, object storage server. Now, as and when the file.txt is transferred, object storage server in its turn maintains its own database. I'm not saying that object storage servers are databases, but the object storage server as a whole, if I consider that as an application, this application uses a database behind the scenes, and let's say that database is a key value pair database. So it's a database that object storage server maintains. As and when you upload the file, the name of the file becomes the key, and the content of the file is the value. So file.txt is equal to hello world. The object storage server stores your file. Now it does not matter, I'm using the extension .txt. As I said, it does not matter whether it is txt, jpg, mp4, pdf, anything that you are trying to send here will be stored as key value pair, right? Now you may ask me details about what kind of database are they using. Hey, I know about a particular key value pair database. Are they using this? So guys, remember that if we talk specifically about S3, it is offered as a service, right? So if I'm offering something to you as a service, I just want to make sure that your job that you want to perform, say for example, you want to, excuse me guys. Okay, back here. Done. So as we understood, object storage server is going to store this file that we have transferred, irrespective of whether it is txt, pdf, jpg, mp4, anything is going to be stored in the database. The name of the file is the key and the content of the file is the value. Next, if I try to access the file, if I want to get it back to my machine, you may feel that you are trying to read the file. But in case, if you look at this, you are trying to send a query to the object server where you say that, hey, I want to find the value for the key file.txt. So when I'm trying to fetch the file, so on the machine it is file because it is kept in a file system like NTFS, ext4, anything that you're using, right? So since it is stored in a file system, you can call it a file. But are we using any file system here? No, Mahendra, we are not using any file system. Rather, object storage server has its own way of storing. So can we call it a file? No, it is not. It's not stored exactly the same way as the files are stored in a file system. So the reason for why we call it an object, it's an object that is stored in a database. Please do not mistake this that I'm saying that the entire object server is just a database. Object server is made up of multiple components. Database that it uses to store the content is one of the components. So that's how your object server functions. Now let's talk about S3. S3, similarly, imagine instead of an object server, we have S3 service and we have the same file. So we have file.txt and the content of the file as hello world. As in when you are going to send this file over to S3, S3 in its turn is going to store the file since S3 is an object storage service. Now consider that it's not a server, it is a group of multiple servers that AWS maintains. And the job of this server is to basically take the file and store it, providing you 11 nines of durability. You might have heard about this term and I'm going to talk about it. 11 nines durability. Right? Achieving 11 nines of durability at the cost that AWS S3 provides me, in my experience, I'm sorry, but I have never seen this happening in an enterprise. If I have to store 10 GB of data, imagine storing 10 GB of data on-prem with 11 nines of durability, right? The cost is going to be exorbitant if you're trying to do that in your own data center. But here in S3, I'm not sure, I'm just taking an example, but maybe I'm trying to store that for $1 or $2 a month. 10 GB of data, $1 or $2 a month, right? Now how it achieves it, we are going to talk about, but I suppose till here, if you've understood object storage, how object servers, they store the object, S3 works exactly the same way, but instead of servers, we have a service that handles the request, right? We use HTTPS protocol as a way to put the file. Those who are aware about HTTPS or those who understand will know that HTTPS has actions, verbs, which are defined as a part of a protocol. So put is basically an action that is performed to basically send some content via HTTPS. Same way get for HTTP or HTTPS is a instruction to basically get some content from HTTP or HTTPS server. That's exactly what is happening using HTTPS over here. And why we can't call S3 as in block or file storage is because it's not performing any block operation to let you create partition or file system in S3, right? And it's not file because you are not using SMB or NFS kind of protocol to get the job done here. It's completely, instead of calling it a file or an object, it's completely an object-based object storage service. Now talking about achieving 11 nines of durability. First of all, S3 happens to be a service there is no resource component that you'll have to create to use the service. Resource component as in you don't have to create a virtual machine, you don't have to install any software. This is all completely kind of a very easy accessible kind of service. I don't want to use the term serverless because then people they take it in a different way. Serverless happens to be another concept in cloud, but I'm using serverless as a very generic word over here. So S3 happens to be completely serverless. You don't have to maintain any server to be able to use S3. Now, how is it that S3 achieves 11 nines of durability? To understand that, we need to talk about what is known as AWS global infrastructure. So as far as AWS global infrastructure is concerned, global infra, AWS is having data centers. Now consider these circles as data centers. Multiple data centers, they make up what is known as an availability zone. This is for redundancy, such that if a particular data center goes down, you can still have your resources and components that you may are using from a particular service accessible. Same way here, availability zone, if that becomes a single point of failure, AWS provides us not one, but 2 or 3 different availability zones, such that if one fails, second takes over and you can continue working or having access to your data. All of this collectively are known as region, as we all know. Collectively known as region. Now, achieving 11 nines of durability, imagine you send a file, file.txt, and you want it to be stored in Amazon S3. Amazon S3 uses a resource component called bucket, and I'm going to talk about bucket soon, but consider that as a logical placeholder, logical component that is created to store the objects that you are going to send, because there are many people, those who are using, or there are many companies, those who are using S3 as a platform to store their data. How will you uniquely identify your own data is via the bucket that you have created. A unique bucket name will be given, right? Unique around the world. That means no other account or no other person will have the same bucket as mine that I'm going to create. So once we have that bucket, if you are going to send the data to the bucket happens to be a regional component. Any bucket that you'll create happens to be a regional component. As in when you're trying to send a file to the bucket in its turn is going to utilize all the data centers and all the AZs which are part of it. So imagine you've sent the file to the bucket. I'm just taking this as a hypothetical example. Maybe, what I'm saying is maybe, I don't know, I mean specifically I don't remember a number, but your file which is being sent to the AZ, it ultimately goes to the data center. Imagine a data center having 5 storage boxes, maybe SAN, storage area network. Across each SAN storage in a single data center, the file that you have sent is copied multiple times. That means in a single SAN box, maybe there are 3 or 4 failure domains or failure groups. That means there are 3 or 4 controllers in a sandbox. In each controller, it maintains 5 copies of it. Let's take an example, right? So if 5 copies in each SAN box or storage boxes, there are 5 storage boxes in each data center. So 5 5s are 25. Imagine if one data center maintains 25 copies and there are 3 data centers, there are 75 copies in each availability zone. 75 threes are, now you can do the calculation, maths calculation, and you'll find those many times the file is copied and being maintained. So if one storage box goes down, or if one of the failure group goes down, or maybe an availability zone goes down, your file will always be accessible. It's going to be it's going to be there in the data center. It's going to be there in the global infrastructure that AWS maintains. So bucket being a regional component as in regional component always has visibility to all the availability zones, and thus all the data centers which are part of the availability zone. So whenever you send a file to a bucket, file is maintained in a way that it can provide you those 11 nines of durability. Now mind it, we are talking about durability, and durability applies to data. Right? Durability does not apply to, let's say we take an example of a service, right? A service, when we talk about service, we talk about availability. We are talking about 99.9% or 99% availability. We are talking about a service, whether the service is going to be available to accept the request or not, right? Requests like put, get, is the service available to take the request? So whenever you send a file to S3 as the service, whether S3 is available to accept the request to upload the file or download the file. The storage part differs here. I mean, even though it is part of S3, the storage part differs, where the storage data durability is maintained even if in case S3 service goes down for maybe a minute or two. So for that minute or two, the service is not going to accept, maybe it is not going to accept get or put request. But is it going to affect the data? No. The data is going to remain as it is. As and when the service comes up back again, you will have access to your data. Now, unless and until a region goes down, which is very unlikely, but we can't say that a region cannot go down. Maybe as there was an old example, maybe dinosaur steps onto all the data centers, or all the availability zone, they go down simultaneously. You may never know. So if the region is down, the data may not be accessible. But as far as the service is concerned, the service layer and the data layer differs. The availability factor is associated with the service, whereas the durability of the data is always associated with the storage part, the data part itself. Let's have a look. Sorry about that. Now let's go ahead and create a bucket over here. I know you may be looking at S3 service on the management console, and you may be having questions about, Mahendra, can you talk about directory buckets or table buckets? But guys, today's focus is only going to be on general purpose buckets. Maybe I'll talk about directory buckets and table buckets when we get into other data related or analytics related things, maybe another open masterclass. So the focus is going to be on general purpose bucket. If you see here, I've already created some of the buckets. Now let me go ahead and create one more for the demo. So I'm going to click on create bucket. You need to have permission. If you haven't been through the previous IAM open masterclass, I would request people, those who are looking at the stream right now, or those who are going to watch this later, please go ahead and have a look at IAM Masterclass. Uh, that will help you in understanding what permissions am I talking about. So if I have permissions, I can go ahead and create bucket. Now here, I'm going to provide bucket name. As I said, bucket happens to be a logical placeholder for keeping all the files that you're going to send, right? So let me choose a name, and let me choose a name maybe that is already taken up. Let's say AWS demo. If I scroll down and try to click on create bucket, come back here and you can see bucket with the same name already exists, right? Bucket name must be unique within the global namespace. So you need to be aware about this. I'm going to choose a random number for AWS demo. Let's say 321. Let's try to create a bucket now. So there you go. So we have AWS demo 321, and I'm in North Virginia, and it has created the bucket in North Virginia. The bucket is created. If I click into this, I will have the facility to upload, download the objects over here. Now, before we get into anything else, I wanted to talk about the bucket. Now, since we have created a bucket called AWS demo 321, that's the name of our bucket, how are we going to access it? So you need to understand this. HTTPS, the name of the bucket, dot S3 dot Amazon AWS.com, and after this, whatever file you upload, the name of the object, let's say I upload a file called demo.txt. If I upload a file called demo.txt, the whole address for it is going to be https:// the name of the bucket .s3.amazonaws.com. This is going to be constant, and after that, whatever object you might have placed in the bucket, the name of that object, demo.txt. Now you may wonder that this demo.txt that you enter as a part of a string that basically completes the complete path for demo.txt, how you're going to access it. But this demo.txt is taken as a key. This is a key. So when you are sending a request for the key to access, it's going to get or fetch you the value of the key. And by the way, just in case if I haven't spoken about, all the data that you're going to send to S3 getting stored in the database, it is stored in base64 format. It is always stored in base64 format, right? When you download it, it is converting it and giving it back to you in the format that you understand. For example, in txt case, it's going to convert from base64 into ASCII, and it's going to present me the ASCII data into my system. But whenever you upload a file, be it MP4, JPG, PDF, TXT, anything, it just converts that into base64 and stores it in base64 format. Yes, of course, I'm talking about movies as well. MP4, if you're having any picture file or movie file, convert it into base64 and stored. So as you can see, it uses HTTPS. Another point I wanted to stress upon is, since it is HTTPS, it uses SSL TLS. So your data in transit is protected already, right? And we have other measures as well that can be implemented as part of transfer to make it more secure and more faster to be able to transfer, which I'm going to speak about in some time. So that's AWS Demo 321. That is something that is created. Now what I want to do in this is I want to transfer a file demo.txt. Let's do that. I'm going to create a file on my desktop. Let's call it demo.txt. And as I said, okay, so I already have this file. Hello world is the content of the demo.txt. Let's try uploading the file. So I click on upload, add file, and demo.txt. Let me click on upload. And as you can see, the file is uploaded. Upload succeeded here. Right? And you can see in the bucket, we have an object. If I click on this object, it's not going to download. Rather, it shows me all the metadata of the object. Now, what is metadata? Let's click on this and have a look. Yeah. So here it shows very clear. You can see it shows key. If you focus on this, key is demo.txt. And metadata that I was talking about is it shows you last modified. It shows you the size, the type of the file, MIME type. Then here it shows S3 URL to access it, the Amazon resource name ARN for the file, then something that it maintains internally, the entity tag, and you can see here object URL to be able to access the file. As I said, you can also, it's not necessary here. You can see it is talking about the region. US-East-1 happens to be the region. It's not necessary that you have to specify the region. If you don't specify, and if you don't recollect that your bucket happens to be in US East 1, or you don't recollect the exact region, you can simply just put in the object, the bucket name s3.amazonaws.com/demo.txt to get the job done. Let me show that. So what I'm going to do is I'm going to use another browser just to get a feel that we are working on a different machine. Here is my Safari browser, and to access demo.txt, I'm going to specify HTTPS copy and just paste it. And what I'm going to do is I'm going to remove US East 1. So as you can see, https:// the first string that you're looking at, AWS demo 321, that happens to be my bucket name, .s3.amazonaws.com is going to remain constant. It's not going to change. And then it is /demo.txt, the name of my file that I want to access, the key, object key. Now, if I hit enter, a very clear message on the screen that it shows is access denied. right? What happened? Let's see. Now this is where privacy or security comes into picture. If I take you back here and I try creating a new bucket, I want you to focus. The name of my bucket is AWS Demo 321. And while I was scrolling down, you can see here, it talks about object ownership where it says ACL disabled and ACL enabled, right? And then just below it, you'll find that it talks about block all public access. What that means is whenever you create a bucket, by default, the buckets are created as private buckets. That means only the owner of the bucket can send files or can read files from the bucket. By default, it is private bucket. Because here we have selected, or we can already see that it shows that selected thing is block all public access. What that means is no public, that means no one will have access to the bucket. And if you don't have access to the bucket, how will you have access to the objects which are stored in the bucket? So that's exactly the reason. And this is what has happened to my bucket as well. Let's go ahead and let's have a look. Let me show you. If I go to this bucket and click on permissions, you can see block all public access is enabled. Since block all public access is enabled, I will not be able to as a different user. That means right now on this browser, I'm logged in as an owner, the one who has created the bucket. So I will have permission here to upload, download, do many things with the objects within the bucket. But since this person using Safari is an outsider, is not the owner of the bucket, he will not be able to because block all public access is enabled. So let me disable this. Let me click on this and let's disable block all public access. What I'm trying to say here is that I do not want to block access to public. So anybody around the world, whether authenticated or non-authenticated from AWS, will have access to the bucket. Mind it, we are talking about bucket. So let's save changes. And here it's a warning. And it's like, hey, this is dangerous as far as security is concerned. And we hope you are in all your senses for when you're doing this. I'm like, yes, confirm. And here block all public access is off now. Since it's off, let me go ahead and let me try to access this again. So I'm going to do that once more. Let me hit enter. Still, we have access denied. The reason for this is we have enabled access to the bucket, but the object has its own set of permissions, right? So here in the permission, you are talking about bucket settings, but when you're giving a request, you're giving a request for an individual object or file. So let me go to the object and see what permission object says. And if I click on permissions for the object, it says for everyone public, there is no read and no write. Only the owner, that is my AWS account, has read and write permission, whereas public has none. Now by default, it's none. Depending on what kind of permissions you have selected, as far as this is called ACL, access control list. Access control list is a predecessor. I mean, we can't say predecessor, but we can definitely use the word that it's an old way of protecting the objects and the bucket. ACL were coarse-grained access control. Coarse-grained is where you cannot define the finer level of permissions. You cannot define permissions at granularity that may be required for some conditions. So here, this is ACL, access control list. As you can see, it is coarse grained, so it does not define in public only a particular set or only a particular group of people unauthenticated can have access to it. No, it's defining it as everyone. So this is coarse grained. To be able to show you, let me go to this bucket owner enforced, and right now it says that ACL is disabled. All objects in this bucket are owned by this account. Access to this bucket and its object is specified only using policies. So I'm going to come to this part momentarily. Only policies if you keep ACL disabled. But for right now, for this demo, I want to. So I'm going to click on ACLs enabled. I acknowledge and save changes. Mind it, this is an old way. Right now, you can see we have bucket policies which are much more easier to work with. And you can define that finer level of permission management for your objects within the bucket. So let me go to object for right now. Click on object permissions. And now you see the edit button is enabled. I can click on that and I want to enable read access to this object for everyone. And I save changes. Permission says read. Again, going back here, same request, hit enter, and there it is. Replies, hello world. Not just the browser, even if I'm using command line and you have tools like curl, as you can see, it shows hello world. This is what was stored as part of demo.txt, show you the demo for the object. Right? Now, next thing I wanted to talk about is, this was an individual object that I was changing permission for. But Mahinder, what if in case we have demo 1, demo 2, demo 1000, demo 5000, you have 10,000, 20,000 objects. Are you going to individually change permission for each of those objects? Is that going to happen? I don't think so, right? So let me create some additional objects here. Now I'm going to do that from command line to just let you know how to use command line. AWS S3 ls is going to list all the buckets that I have, right? And right now, I want to create a file called secret.txt. This is the secret that I want to keep in the file secret.txt. And I want to upload this file. Now I can click here, upload, but just to let you know how to do that from command line is copy secret.txt to S3 bucket AWS demo 321. Apologies, is AWS S3, copy. As you can see, it has uploaded the file, and if I refresh here, the file is available. Also, let's upload okay, we'll have to do that. So 3 files are more than enough here. I have some more files that is uploaded. File 1, file 2, file 3. These are all blank files, but still good for our demo that we want to, that I wanted to show you. Now, ACLs are set for individual files, though from permissions, you have already removed block all public access. But if you go to individual objects, like if I want to access secret, is it going to permit that? So not demo.txt, but secret.txt. Access denied. What that means is I will have to click on secret, go to permissions, again click edit, click on read, and that's how it is going to enable. You will have to do that for each and every object, right? Sorry, Mahinder, we don't have as much time, right? Who's going to have the time? We'll have to deploy a single person for, continuously, and that way it is going to take a very long time for a single person to keep doing that. Is there an easier way to define permissions, keep things secure? That's where we move beyond ACL, and something that supersedes your ACL also happens to be a bucket policy that you define. There it is. So policy happens to be the next permission management component of the bucket, S3 bucket. And if I click on edit, I can use policy generator. You can add a statement from here. This is something that is quite easy, but I also wanted to bring to your attention that we have a policy generator that can help you generate policies. So the type of policy that we want to create is S3 bucket policy. And this happens to be a JSON document. Those who are not aware about policy, again, I've spoken about policies in IAM, the previous open masterclass. Just to reiterate in short, a policy happens to be a JSON document that contains 5 elements: effect that allows or denies, principal, the identity, the user, the one who's going to use it. AWS service basically defines for which service. So we have effect, principal, action, resource, and conditions, right? Now here, this is going to be created since we have chosen S3 as the bucket policy as the option for select policy type. This is going to remain constant, non-changeable, hence it is grayed out. So I want to allow everyone in the world. Now, what action do you want to allow? There are so many actions. I want to only allow get object so that they can get an object as and when they make a request, nothing else. They can't put anything. So it's just a read operation that I'm permitting here. Get object, just one. And for which resource? For the resource, as you can see here, the ARN, that's the resource that you want to copy. That's my bucket name. ARN, Amazon resource name. So here it specifies bucket. I want to specify in this bucket star. That means all the objects. I'm trying to allow all the objects. Add statement. There is a statement for it. I also want to make sure that there happens to be a very, very important file that I have, secret.txt. I don't want anyone in the world to have access to this. No matter what, I don't want anybody to see this. Even though my bucket happens to be public, people have permission to access any of these files except for secret.txt. So I may add an explicit deny to everyone in the world all actions. Maybe I want to deny all the actions for secret.txt. Add statement, and there it is. So allow everything, but in S3, deny secret.txt at all times. There it is. This is the JSON document that the policy generator has created. I can simply copy this and put it across in permissions for the bucket. Save changes. There is bucket policies applied. So we will have access, allow everything, deny secret.txt. So as you can see, while I was doing the previous open masterclass that was on IAM, Identity and Access Management, I spoke about principle of least privilege. What principle of least privilege says in AWS is uh, everything is implicitly denied unless and until explicitly allowed. When everything is already denied, why would you have a deny statement in the policy generator, Mahinder? When it is all denied by default, why do you have an explicit deny? This can be a good use case for deny, where I want to allow everything, but I want to make an exception for a thing or two. I want to explicitly deny out of the entire allow list, right? Now I'm not going to make a change to the object at all. Secret permissions, as you can see, you don't have permission to get object. That is the API response, because that is explicitly denied for everyone with an explicit deny in a resource-based policy, right? So let's check out. Let's check out for demo.txt. Yeah, Maninder, this was already accessible. Let's see for file1.txt. See, file1.txt is blank. Okay, so you will get blank as the answer. We shouldn't get access denied. That's the only thing. So file1.txt. There is no access denied. Since the file is blank, you can see here it is size 0 bytes. We don't have permission error. We don't have access denied kind of an error for this. So that means this is also accessible. But do we have the same thing for secret.txt? Secret.txt. There it is. So for secret.txt, it's an explicit access denied, even though the bucket permission is do not block public access and the object permission is all controlled via the bucket policy that we have created. So core features that I was talking about was bucket that we have created, the objects that you can store inside the bucket, now yeah, I mean, as far as security essentials are concerned, I'm going to talk more about security, but we are going to do that once we are through with some more features within S3. Let me bring that up. Okay. Now next part, one more feature that you have here is you can also create folder inside a bucket. But Mahinder, you said that S3 happens to be an object storage and we don't use file system kind of data structure for storing the objects in S3. Yes, that's true. But since we have been working with file system for such a long time that it makes it a little easier for me to have folder created and arrange all my files and everything within the folder. So they have given us a facility where we can also create a folder within. So let me do that. Let me create a folder. The folder name is folder demo. That's the name of my folder. That's a folder. And inside this folder, I can upload or create more objects, right? Let's do that. So I want to upload this file3.txt into AWS demo 321/folder demo, this folder that we have created. So let me do this. And if I refresh the screen here, you have file3.txt that is uploaded. Now what that means is you may feel that file1.txt, so let me rub this, yeah, file1.txt. So now Mahinder, how am I going to call file1.txt that's already in folder? What you're going to do guys is after Amazon AWS.com, you're going to define folder demo slash file1.txt. Now this entire string that you're looking at happens to be the key and the content of the file will become value, right? So even though you can create a folder that is not the actual folder that you use in your file system, this rather adds an additional string into the key, the name of the file. So if you recollect, I told you that the name of the file becomes the key and the content of the file becomes the value. Here folder demo slash file1.txt will become the key and whatever is the content of the file will be stored as a value in S3, right? That's how you'll be able to access this file. Let's have a look at some more features within this. Okay, so I'm going to talk about some of the features in properties here. Let's start with the first one, bucket versioning. Right now you can see bucket versioning is disabled for me. When bucket versioning, now this feature, if you can read about it, but just to let you know, bucket versioning happens to be a feature that can be enabled. Once enabled, it cannot be, it can be paused, but it cannot be disabled again, right? So what bucket versioning does is till the time bucket versioning is disabled, every time you try uploading the same object to the same bucket, it replaces the object. So let me show that. So let's say I'm trying to put demo.txt file again. Before we do that, let's demo.txt. I just updated the date and time. And now what I want to do is I want to upload demo.txt once again. I want you to keep an eye on the last modified. The key remains the same. The content remains the same. It's not going to change 12.0 bytes, 12 bytes. But something in last modified is going to change. And that's what I want you to focus on. Demo.txt uploaded. Here it is showing 18th Jan 10:38. If I refresh, now it has changed to 11:08. What I'm trying to say here is when bucket versioning is not enabled, by default, every time you try uploading the same file, it is replacing the previous one. Replace, that means the previous content is getting overwritten. As and when you come here to properties and you enable bucket versioning, what AWS does is it enables multiple versions of the same file to be maintained into a bucket. Definitely it comes with a cost, right? Because you're trying to store multiple versions. But once it is enabled, you can store multiple versions of the same file into the bucket. So let's go ahead and do that. I go to properties, bucket versioning, enable. Now, once enabled, as I said, you can only suspend, you cannot disable bucket versioning. Suspend is it will stop performing the job of storing multiple versions of the same file if you upload it again and again. Let's see this. Since I've enabled, I go to object. If I click on demo.txt, hello world is what it stores. Let me upload the same file again and again, maybe with different contents. So let's do this. Here I'm going to make a change to demo.txt. And what I want to show is this is version 1 of demo.txt. That's the change in the file, right? I upload this file. Let's do it again. This is version 2 of demo.txt. So we have one main demo.txt which has the content as hello world. But apart from that, we also have, now if I refresh, you will see an additional button here that shows up, show versions, which was not available till the time I enabled the bucket versioning. So if I refresh, the button shows up. If I click here, you can see that this is the main this is the main demo.txt. But now you can see demo.txt being repeated as this is the main one, and then the latest version that you have, latest, that means the one which you uploaded recently, will be the active version. The active version is the one which will always be shown to you. But apart from the name and type, you can also see that it shows you version ID, right? Let's try and access demo.txt. It's going to show you the most recent version. Most recent version is version 2. So it shows hello world, This is version 1 of demo.txt and this is version 2 of demo.txt, right? But Mahendra, what if in case I want to access version 1? If you want to, you need to know the version ID. And here, when you are trying to make the request, you're just going to put in version ID is equal to demo.txt and so version. So okay, we can click on, don't want to get into troubleshooting this, but I suppose since it was showing us permission related, now if I access, and you can see here, it shows me since this is JAA0, that's the version ID. As you can see here. So I say the name of the key, the name of the file demo.txt, and then we specify question mark version ID, where I is capital, rest everything else is in small letters, version capital ID is equal to, and you specify the version ID, the actual version ID from the file, and you get to see that file. So here it shows that this is the previous one, this is version 1. Now, where is this going to be useful? What's the use case for this? We understand, Mahendra, you said that instead of replacing the file, it's going to maintain all the versions of the file that you try uploading. The use case can be point in time restore when you are trying to work with backup and restores. This can be a good use case for point in time restore. I don't want to restore the most recent version of it. Rather, I'm interested in restoring the file as it was on January 18th at 11:11 a.m. Right? I want to download the file at that. So point in time restores can be a good use case for this. Second good use case, let's say I delete the file demo.txt. This file is deleted from the bucket. And maybe that was a mistake that I made. I just did it, right? So what do you do now? Is it possible to bring the file back? Only if in case you have versioning enabled, you can. So if you click on show version, it has not deleted the file, but rather to the active version of the file, what it has done is it has put in a type called delete marker. That way you may feel that the files are deleted, which are not actually. It has just put in a delete marker. The files are not deleted from the bucket yet. So will not be shown in the actual listing of the object, but if you try to see with all the versions, it will show you this. Now, how do I bring it back? How is it possible for me to bring demo.txt back? You just click on the show version, select the delete marker, and you delete the delete marker. Delete marker hides the file. So I'm going to delete the delete marker. And yes, I want to permanently delete this. Since the delete marker is removed, the file is back. We have demo.txt that works. Right? Now, I'm sorry, I just probably skipped my mind. I was talking about the use case, right? The use case for version. Now, what's the good use case for S3? Mahinder, can we use S3 for storing database? What kind of uh, uh, what kind of applications or what kind of deployment can I use S3 for? Now, guys, S3 is an object storage. It is not a block or file storage. Block or file storage is the one which is a good use case for frequently accessed and frequently written data. What do you mean by that? Now, this is a very good use case. Elastic block store. There is a block storage that we are talking about. This is a good use case for uh, random storage, or rather data that frequently changes. Data that changes frequently. That means you have a database that is frequently changing, writing data into the database. Now, can I store the same database on S3? No, we can't. We cannot. Though we can put database backup to S3, backups are not frequently changed. Rather, once they are written, you will only download or read the backup file when something goes wrong with your actual database. So data that is not frequently changing is a very good use case for S3. For example, static assets of your website or your application. Static asset as in a picture file, a movie file maybe, some kind of GIF animation, something that is not going to change very frequently. The reason for why you don't use frequently changed data and you try to keep it in S3, because S3 as an object storage service does not provide any processing capability. That means you can't send an instruction to S3 to update a particular record in a table of the database. You can't. For example, let's say we have a single file of 800 GBs, a single file, right? Of 800 GBs maybe. And imagine if that is text file. I mean, Mahinder, that's a hypothetical example that I'm taking. So imagine we have a single text file and filled with so much of data, so much of text, that the size of the file is 800 GB. Now, if you ever want to change the file, you cannot send a request to S3 to make a change on line number 1022. Not possible. You will have to download the entire object, make the change in the file at line number 1022, and re-upload that object again for it to have the latest change. Imagine you start doing that for frequently changing data where a data is needed. Maybe the application needs the data. Downloading the entire 800 GB, making a change and re-uploading entire 800 GB. I don't think so. None of the applications are going to withstand that kind of latency, right? So you don't want to use that for frequently changing. So S3 is not a good use case. A very important statement that you need to remember is not a good use case for frequently changing data, right? So what is it good for? It's good for what we call it as a worm model, WORM. Write once, read many, right? So you write the data once, but if you want to access the data multiple times. For example, I've created an application that is an executable file. I want to distribute the executable file to all the branch offices around the world in my company. You can keep that file into a bucket and share the link for that particular object with all of your team around the world. They will be able to download the file. So if you see, it's a good use case for write once, I uploaded once, but I read many times. I downloaded the file many times. It's a good use case for that, right? Not for frequently changing data at all. Let's move on to the next part. Every resource in AWS, you can provide a tag, right? A tag makes it a lot more easy for me to search, to basically sort resources based on application, based on component, environment. So you can keep creating tags for resources. I'm talking about S3, but you can keep creating tags for any resource, be it EC2 or S3 bucket, or VPC related components. You can define you can define tags for all. You can create a maximum of 50 tags. Guys, those who are wondering about tags are nothing but key value pairs. These are just kept for the purposes of ease for search, and you want to sort, you want to categorize, you want to track storage cost based on the tag. So let's say tags can literally be just A is equal to B, as simple as that, or it can be as complex as defining environment. Let's say this is production component, this is backend. Then this bucket is used for the application AWS demo app. That's the name of my application for which the bucket is being used, right? So if I click on save changes, those are the tags associated with the bucket. Now, where is this going to be useful? This is going to be useful. Say, for example, I'm working with the cost of a particular application. My team wants to know, or my boss wants to know that, Mahendra, I wanted you to find out the estimated cost for running AWS demo app, right? I know this AWS demo app is using one bucket. It's using 5 virtual machines, one RDS database, and maybe one elastic cache database as well. So what I can do is I can go to each of these services like EC2. So I can go to EC2, and maybe this virtual machine, I can put up a tag for this virtual machine, and let's say manage tag. I can add a new tag that this is part of the application AWS demo app. So there is AWS demo app key value pair, the tag for this resource as well. I can go to cost, billing and cost related service, and I can just try and search that I want AWS, the interface, to fetch all of the resources which are having a tag of app is equal to AWS demo app. It's going to present me the S3 bucket, this EC2 instance, and it's going to present me the other components that I'm using with the application. And that way I can get to see that these are the resources of different services which are coming together, stacking up to empower the application. And then maybe I can work with the cost. What is the cost of storing the data in S3? Let me see the estimated cost for it, and then for EC2. And overall, we can come up with that. This is the approximate cost for running the application, right? That is just an example that I've taken. What can be the use case for tags? Let's go to the bucket again. So those are tags. Next is encryption. Can we encrypt data that is kept in the bucket? Yes, you can, and that's recommended, right? You can see here, for this bucket, server-side encryption with AWS S3 managed keys are used for encrypting. Server-side encryption is automatically applied to new objects stored in the bucket. So all the data that is stored in the bucket is by default encrypted by a key created by S3 service itself. So it itself creates the key, keeps it in a different server, and then uses that key to encrypt the data that is kept probably on some other S3 server. So that way the keys and data are separate. So encryption, but of course we all know that as far as data protection is concerned, once you kept the data encrypted, it becomes a lot more difficult for anybody to be able to read the data unless and until you have the key. So I can click on edit. If you want to disable the bucket key, you can disable. Recommended is to keep it enabled. Now you can use S3 managed keys, or there is another service called KMS, Key Management Services. You can ask for the key from KMS as well, right? So that's for encrypting the data. We'll talk about what is intelligent tiering in a bit. But right now, let's go to server access logging. Now, server access logging is a feature of S3 bucket. If you enable that, it will keep a track record of who made the request for which object, from where, and what was the action that was taken. For example, if I give access for this demo.txt to the entire world, all of you will have access to demo.txt, right? If you try to access it from anywhere, you can. By default, there is no log maintained for it. I don't know who all are trying to access it, right? So if I do this, if I go to properties and I say server access logging is enabled, and you will have to define a bucket where you're going to keep this. Maybe let me say that I want to keep all the access details into this folder demo. Now, all the files that you will try to access in S3, there will be a log that will be created in folder demo for the same. So let me show it in AWS demo 321 in folder demo. Since we haven't accessed any file, there is none. So let me access demo.txt. This version of the file and also the most recent version. Since we have enabled it in some time, I'll have to come back in some time. It's going to happen eventually. We'll find some additional files that will be created in folder demo related to your server access logging, right? So what information it's going to store is who accessed it, what was the IP address, and once I get the IP, I can definitely get the location from where it was accessed as well, right? Where is it going to be useful? You can use it for your own audit purposes, I mean detailed audit purposes, or maybe that information can be very useful for if your company is trying to decide that we want to focus deploying the application for people, those who are trying to access the PDF file. Maybe let's take an example here. I'm trying to start a yoga business, right? A health related business. I'm offering yoga to people. And for yoga, I give out some books, PDF files for free to people around the world. Now, I want to collect statistical details for which region in the world or which place in the world most of the PDF files are downloaded from. That shows the interest of the people, right? And that is where I may start my business from. I want to focus on people, those who are interested in maybe India or maybe some other region, some other location. I may want to focus there. So to get details, statistical details about how many times the PDF file has been downloaded and from where, you may want to enable the server access logging for it. We'll talk about CloudTrail. Let's talk about CloudTrail here. If I talk about CloudTrail here, CloudTrail basically is a name of a service that stores event details. Let me show you. Now this shows event details here. If you click, like it says who did what, from where, when, which resource was affected, right? So for example, admin, I'm logged in as admin. So admin, the user, in this account, at this time, Zulu time is UTC. For this service, what was the action? Put bucket policy. That means he had put a bucket policy in US East 1 region from this IP address. Let me show you this IP address. This IP address belongs to me, as you can see here. And if we go IP fingerprinting, that shows exact location where I am. And now, then next it shows the user agent. I'm using Chrome for doing all this action, so it has recorded that. And then what is the bucket policy that was put? This is the bucket policy. Another bucket policy that was put was for server access logging, to allow logging for it. Now if we go back, I hope so. In folder demo. No, not yet. Okay. So guys, that was about CloudTrail. So CloudTrail will let you record all the user actions on your bucket, if there is configuration changes and all which are happening, which makes it a lot more easier for you to have an audited report that can be created and understood who did what to your bucket. Then next is event notification. Event notification, if you configure, every action that is taken in your bucket, for example, uploading the object, downloading the object, it can generate a notification for it. And the notification can either be sent to your mobile for every action, right? Through email or through SMS, or it can be sent to other services to take actions. For example, every time somebody uploads a picture file into this bucket, I want the event notification to send an event and invoke another service called Lambda. And I may instruct Lambda, writing a function in it, that means coding into it, that I want Lambda to perform the watermarking. I want to put my own company's watermark on every photo that is uploaded to my S3 bucket. So completely kind of, it's very useful if you're trying to create a serverless completely serverless kind of setup, right? Not just that, I mean, that was just a use case example, but it can be used for other purposes as well. As said, every time you do any action related to the object, event notification can send notification to other services or on your own mobile SMS or mail. Next is use an accelerated endpoint for faster data transfer. By default, all the data transfer that happens is from your location to S3. Now, let's use Blackboard for this to understand. This is your S3 bucket. That's your S3 bucket. And this is who I am with my own machine. Now what I want is I want my data to be transferred into S3 bucket. Right now, as of this recording, I'm in Mumbai. And the S3 bucket that I'm talking about is in US East 1, that is North Virginia. It's too far away, right? What happens is the distance introduces latency. So longer the distance is, it's going to introduce the latency, more and more latency, and it's going to be slow for me to be able to transfer the data. So if you feel like your data transfers from your machine to the bucket are slow, you can enable what is known as transfer acceleration. And when you enable, definitely at cost, it's not going to be free. But if you enable it, what happens is AWS uses its edge location or point of presence. And from edge location to the S3 bucket, these are all private network of AWS that AWS maintains, and these are running in terabits per second, TBPS kind of thing, right? So they have faster speed, plus since this is a private network maintained, probably they are using cold potato routing, which also enhances or makes it a lot more faster for them to transfer the data. So what you can do is you can take advantage of this from Mumbai, your home or your location. You are taking internet for only this path. Mumbai to Mumbai is definitely going to be low latency. So all the data that you transfer will go to the edge location, and from the edge location, it's going to use this super fast highway to send the data to your S3 bucket. This enhances the overall speed at which the transfer can take place. That's exactly what transfer acceleration does. Right? If you click on this, you can click enable and you'll be able to use transfer acceleration for sending the data. Then there are other things which can be useful, guys. You can also host a static website. Static, I mean, there cannot be dynamic content. It cannot perform the task of like going to a database, fetching the details and all. But if you have a static website to be hosted, you can definitely do that from S3. Let's look at some more features that I have in the list. Okay. Also wanted to let you know that S3 now has improved a lot. It's much more faster. The reason is S3 by default implements that parallelism that is needed for faster data transfers. You can definitely benefit from transfer acceleration, but just to let you know, giving you an example, with S3, what you can do is you can introduce multi-part upload for a file. Let's see this. You can Google S3 multi-part upload, uploading and copying objects using multi-part upload. So it's not available on the management console, but you can definitely do that from command line. We have AWS multi-part upload. Yeah, there it is. Create multi-part upload. You can use AWS S3 API to be able to do that job. But once you do this, what's the benefit of it rather than looking at the technicality of what's the benefit of doing this multi-part upload, Mahinder? Let's look at the use case. Again, I'm going to bring up the Blackboard for this. So we have S3 bucket, and I want to transfer file from here into the bucket. The file happens to be a single file, but this single file happens to be 100 GB in size. Now, what kind of file are you uploading, Mahinder? Yeah, we have a single file that is 100 GB in size. Those who are not aware, by default, S3 does not have any kind of restriction in how much data can you put into S3 bucket. Unlimited, you can go to petabyte scale. There is a limitation though for an individual object that you can keep, but that goes in terabytes, right? An individual object that you are going to upload to S3 bucket can be a maximum of 5 terabytes, I suppose. So if I have 100 GB file that I'm trying to upload from here into the bucket, let's say I started the upload process over here shows me that you have completed 95% of it, right? At 95%, maybe you have electricity outage at your location. Yeah, it took almost, let's say I have a very slow internet speed, and maybe it took an entire 2 hours to basically transfer this 100 GB of file into the bucket, but at 95% I have electricity issues, right? My system, it just stopped working. So did you complete the upload process? No, we did not. Now, once you have electricity back at your location, if you try uploading the same file again, it's going to start from 0. And from 0, then it's going to take another 2 hours to maybe reach 95%. How do you tackle this issue? So we tackle this issue by dividing this single file into multiple parts. Let's say I divided the file 100 GB file into 10 parts, so 10 GB each, right? How are you going to divide the file? Guys, we do have API calls. Right now that facility is not available from the management console. But if you're using API calls, you can definitely do that. We have facility through API which can perform the job. Now, once you have these 10 different parts, all the 10 parts can be uploaded to the bucket simultaneously, parallel upload. Wow, so that means all the 10 parts are getting uploaded. That actually improves. This is what is known as parallelism, right? You are trying to use a parallel architecture for uploading the same file, but at 10 times the speed in a way, by dividing into 10 parts. Another benefit you will find is, imagine you have already uploaded all the 9 parts, 100% complete, 9 parts. It's only at the 10th part that your electricity failed here. Now, once you have electricity back and you have everything up and running, energy is there, you only have to upload this 10th part to the bucket, reducing the amount of time to finish the upload. And once you have uploaded all 10 parts, we have basically an API call to collect all 10 parts and create a single object out of it, right? In old times, again, there is no use, Mahendra, there is no use if you are creating 10 part upload and it's just a single S3 server that's going to handle, a single S3 IP that's going to handle all of the parallel multi-part upload. So guys, if you have a look at this, let me show you that S3 S3, if you try to look up the IP address for S3, it shows you multi-value answer. If you can see this screen, it provides you multi-value answer. That means it's not a single IP address. There are multiple IPs which are working behind the scenes. So if you've created those many parts to upload, probably it's going through multiple of these servers. These are IP addresses of servers, if you can take it. I mean, it's a service, but doesn't hurt to understand it as a server. So all of these servers are working individually, and finally, when all the parts are uploaded, you can join them all together. Right? So that's another feature that can speed up the upload process. It's not just for uploading, but also for downloading. So for upload, we call it multi-part upload MPU. And for downloading, we call it byte range. Same parallel architecture for when you're trying to download this. So if you want to download the object, we have byte range that does the same thing, but this time for download process. So we have parallelism in download as well, right? But Mahendra, you can't show us anything over here. Guys, this is just a management console. A management console is not always the only way how the data is uploaded or downloaded for S3 service. Rather, it's an application. Let's say I'm writing an application, and this application simply collects the selected folder from a person's computer and sends all the data to my service called worldstorage.com. So let's say I started a new business venture, and my business name is worldstorage.com. Anybody can upload as much file as you want. So what I do, is I create an application. That's my website, worldstorage.com. And I let people to upload their files into worldstorage.com. They can store their files, and I've created a nice interface over here giving them all the details in the navigation menu, and here they can see all the files and folders they have uploaded, and here they will have app options like settings and profiles and all that. So that's just an interface, but imagine if somebody is trying to upload, maybe worldstorage.com in the backend is using an S3 bucket to store all the data. So what worldstorage.com application does is every time somebody uploads a file, worldstorage.com sends an API call to S3 bucket to store the data, and maybe it maintains its own database for metadata and other details that it wants to maintain at its level, right? So it's not always the management console that we are using to upload the files and folders like for the demo that I have shown over here. It's the application which is the actual use case. And when you're doing that, for all these facilities like multi-part upload that I just spoke about and all, I said that these are more programmatical. It's not that you don't have command line, you definitely have it. You can have a look for it and you can search for it in Google. You will definitely find some examples for it and can use that for uploading. But if you do that, it's probably happening through an application into S3 bucket by sending an API call. So that was to optimize the performance for as far as the uploads and downloads are concerned. Let's look at the next portion. So fundamentals, core features, security essentials. Now let's look at cost management. Guys, the moment we start talking about cost management, how do you control the cost while at the same time making sure that all the data that you need is available in S3? Now for that, S3 gives you an option of storage class. As you can see here, a storage class. Now, with the help of storage class, you can implement what is known as hierarchical storage management. I don't know how many of you are aware about it, but in an enterprise, we do use for performance and at the same time making sure that we have a better cost. We are not paying exorbitant amount for data that is not being accessed, right? So you want to make sure that you're placing the data in the right place, in the right resource for as far as how expensive or how economical the resource is going to be as far as storage is concerned. Let's take an example of this. What is hierarchical storage management? Hierarchical storage management in an enterprise looks like this. For your machine where you're trying to store the data, the storage basically comes from a sandbox mostly for most of the enterprises. And inside SAN, we have logical unit number that is presented as a hard disk for your server. Right? Now this logical unit number is not made of a single disk. This logical unit number is made up of multiple disks like SSD, solid state drive, which is one of the most expensive one, and maybe then it's also using serial attached SCSI, SAS disk, nearline SAS disk, and maybe a tape. Now, if you look at the cost spectrum of all these storage options that we have, SSD happens to be the most expensive and most performant. SAS, serial attached SCSI, happens to be not as performant as SSD, but still much better as far as performance is concerned and a little economical than SSD. Nearline SAS, not as performant, but more cheaper. But when we go to tape, where the data is stored in tape, not expensive at all. It's going to be the most economical, but it's going to be the slowest, right? So I want to make sure that my SAN is intelligent enough. I want to make sure that my SAN is intelligent enough to store the data where frequently accessed data, hot data, is stored in SSD, data that is not accessed for more than a day must be moved to SAS because my SAS pool happens to be bigger. It's not as expensive as SSD, so my enterprise has bought a lot of SAS disks. So hot data, right? Data that has not been used for maybe like 10 days or so must move to nearline SAS. Data, that means if a file or a folder is not being touched for more than 10 days, I want SAN to work intelligently and automatically move the data to nearline SAS. And then if it is not being used for more than 30 days, I want it to move to tape. So this way, by implementing this hierarchical storage management in an enterprise, enterprise makes sure that they have all the performance that they need from the storage, but at the same time keeping the storage cost down. This is exactly what is implemented by making use of storage classes in S3, right? Now, if I click on upload, you'll find under properties, this is the default storage class. If you do not specify which storage class you want to use for object that you are uploading, by default it applies standard, right? S3 storage classes. A good thing to look at in documentation. Right? Now, just to let you know, since we are talking about it, frequently accessed data can be kept in standard storage class. There's more like, if you can think about it, it's not that it's more performant like SSD, but definitely if you are going to access the data, remember, if you recollect, I told you that S3 is not a good use case for frequently changing data. It's a good use case for frequently accessed. So how frequently you're going to access it, right? If it is more than, as you can see here, it says if it is more than once a month and you want to keep it there, you can use that. Next is more than once a month. Next, let's talk about intelligent tiering later, but next one, standard but infrequent access. It's standard hot data, but it's infrequent access, probably once a month or twice a month that I'm going to, right? So you can keep it as standard IA, infrequent access. My data is not going to be frequently accessed. Next is one zone IA. This is cheaper because here it's not going to provide you the same kind of redundancy. As you can see, unlike other classes that we have seen, it uses only one zone. So one zone IA is a good use case for if you already have that data available and you can easily recreate the data. For example, I have got two buckets, movie bucket and thumbnail bucket. Movie bucket contains all my movies, right? The thumbnail bucket that I have contains thumbnails of all the movies. So movie bucket, maybe I'll keep it as standard IA, but for thumbnail, I'll choose one zone IA. Reason is, if I'm losing the zone, if I'm losing the data as well, I can recreate the data using the video files which I've already kept in another bucket. So if the data can be regenerated easily, you may want to keep that kind of data into one zone IA. Now, rest other things that you're looking at is all Glacier. Glacier is an extremely cold data that you're not going to access for more than say 3 months, or you're looking at 6 months down the line. You just want to archive the data and kept, because your business may need the data in 90 days, 180 days or 365 days. You can choose Glacier as the archive. So Glacier, you can imagine as if you're trying to store the data in tape. right? As we go for tape archives, if you're storing the data which you're not going to access for uh, maybe 6 months or a year down the line, you can keep it in Glacier. Now, this is when you are aware about your access pattern, like standard IA, one zone IA. Mahinder, I can choose all of this, but only when I'm already aware about how the access pattern is going to be. But what if in case if I'm not sure what my access pattern is going to be? Then you may want to use intelligent tiering. Intelligent tiering is when the access pattern is not known. So that way it uses its own intelligence S3 to understand your access pattern, and accordingly it will choose which storage class is going to be good for the purposes. Right? So these are all storage classes through which, in a way, the way how enterprises implement hierarchical storage management, we are also implementing using storage class. This way, it optimizes the cost. Let me tell you how. If you are going to keep everything in standard, even though you're not going to access that, you are paying an additional price for it, right? But if you can categorize your data as per your access needs and define a proper storage class for each of them, you will find that the mix of the storage classes will end up reducing the overall cost that you're going to pay in the bucket, or for all the buckets in the account. If you want to do that for all the buckets, which you must, right? You don't want to end up paying an additional money. Okay, moving on to the next part is, yeah, so since we were talking about redundancy, one zone IO and one zone IA and all, why not talk also about uh, availability factor, wherein the bucket that you have created, the bucket happens to be a regional component, right? So in regional component, Mahinder, what can go wrong? A maximum of an availability zone that fails, or second availability zone that fails, but that's fine because my data is safe. What you are not factoring here is, what if in case the entire region goes down? What are you going to do then, right? So I'm picking up a topic from designing for scalability here, but that's fine. I'm going to talk about advanced security and monitoring in a bit. Let's move on and talk about the redundancy factor that you can introduce to make sure that your data is safe, not just in a single region. I mean, not just in a single bucket, but also making sure that all the data that you put in this bucket must be replicated automatically to another backup bucket that you may want to keep for your mission critical application, right? That's where cross region replication comes into picture. Right now, I have AWS Demo 321 in US. Let me create one more bucket. Let's create one more bucket, but this time I want to create it in Mumbai. Create bucket. And let's call it AWS Demo 321 backup. So 321 and 321 backup, right? What I want to do is I want to make sure that all the data that comes to this bucket must also be automatically replicated to the next one, so that if at all the original bucket goes down and I'm not able to access the data, the bucket will only go down if the entire region goes down, because it's a regional component. But if that happens, my application has access to the data from the backup bucket, right? To be able to do that, you go to management and you can define cross region replication rules. Let me do this. Create a replication rule. rule 1, enable. This is my source bucket. Now, what is going to be the scope? Is it going to be applicable for all the buckets in the object, or do you want to limit the scope by defining prefixes, right? Only certain files or certain prefixes like .jpg, .txt. I want to do that for all the objects. Is your bucket in the same account, or if it is in a different account? If it is different account, then you will have to specify the 12-digit account ID. Mine is in my account, so I'm going to choose the next bucket that we have created for this. Apologies. Let me do this again very quickly. There it is, AWS Demo 321 backup. Choose that. Replication requires versioning to be enabled for destination bucket. I can click on enable versioning and it will do that automatically. It's in Mumbai. Yeah, I can create a new IAM role for this so that S3 has access to the other bucket. Replicate objects encrypted with KMS. So you can select that. Destination storage class, choose the storage class of the replicated object as original, or if you want to change it, you can change it from here. Maybe I want to keep everything as intelligent tiering for this destination. Now here, what replication option do you want to choose? You can choose as per your needs. Sorry, I don't want to enable this. I don't want to choose that. Now, this is one of the most important things. By default, whenever you enable replication, cross-region replication, what happens is the pre-created objects are not copied. They are not replicated. So you may want to enable this, yes, replicate the existing object, and you may want to select, I want to. Create a batch job operation. Yes, I want to do this. Now it is asking for report destination. Do you want to generate completion report? No, I don't need it. Since it is a demo, I'm fine without the report. Now once that completes, you can see the status here. It shows preparing, and once completed, I'll come back and show you that a replication works for the existing object as well as the new one. So this is 3-to-1 backup and this is 3-to-1 in some time. But as and when I create a new object in this, let's upload a new object in AWS Demo 3-to-1. CP. I want to upload file 9. It's a blank file. AWS S3 CP, my bad. So file 9. I hope I'm doing it right. Okay, file9.txt. So we have file9.txt. Still, the batch job is still being performed. So guys, as I said, it's going to just give it some time, and I'm going to come back and show you that all the objects which were there in AWS Demo 321 will be replicated to this backup. And is it necessary to provide a name called AWS Demo 321 backup? No, absolutely not. The name of the bucket can be literally anything. Right? This is called cross-region replication that provides you regional redundancy as well, if you are working with such a mission-critical data for your application. Okay, next part I wanted to show you is also that was left out. I'm really sorry. This is again part of your designing for scalability. Life cycle configuration. Now, the use case for lifecycle configuration in a bucket is wherein all my files are in standard storage class. I want to make sure that if in the standard storage class, it's not being used for more than say 15 days, I want it to move, transition to standard IA. I don't want to end up paying the cost for standard if it is not frequently accessed. So why not change the storage class of the file to standard IA if it is not being used for 15 days. Then in standard IA, if it is not being used for more than 30 days, I want it to move to Glacier. And if the object is in Glacier for more than 365 days, after 365 days, I want the file, the object to be deleted at all, because then I'm not going to need it, right? This is called policy-based data management in generic terms, in like normal in your data center. If you've been working here in your companies, not in the cloud, but in the data center, we call it policy-based data management. You have defined a data management policy, and that's exactly what your life cycle configuration is. I can create a life cycle configuration, migration and deletion rule. That's the name of it. Apply to all the objects. I acknowledge. Transition current version of object between storage classes, right, to standard IA days after object creation to storage class transition. So days, 15 days. Add next transition. After standard IA, I wanted to move to Glacier Deep Archive. From standard IA, it will move to Glacier Deep Archive after 30 days, right? Last, I also want to do this. Permanently delete non-concurrent versions of objects. So you can define number of versions and after how many days. Or maybe expire the current version of the object after 365 days. So this is transitioning in 15 days, in 30 days, and then after 365 days, I just want it to be deleted. You can see here. Object expires. And after expiry, you can define delete expired object, delete markers, or incomplete multi-part upload. It may happen that 9 parts are uploaded, 10th part you just forgot, and 9 parts are still waiting. You are being charged for it. So you want that to happen. You can select delete incomplete multi-part upload after 5 days. Now, these are the rules that you can specify. You can create a rule, right? Now, there are some missing these things. It's not 15 days that you can provide, because a minimum of 30 days required before transitioning to standard IA, because there is a commitment period for standard IA. There is a commitment period of 30 days. You can find it here. So there you go, file9.txt appears. And if I change, and you can see here, minimum storage duration, you're committing for 30 days. So that's the reason why it was showing this error over here. But otherwise it would have worked in lifecycle policies. But I suppose through this you understand what I'm trying to talk about. So after 30 days and maybe after 90 days, the rule is created for the entire bucket. Transition to standard IA, then Glacier Deep Archive, then expires. So policy-based data management. Then let's look at some more. Inventory configuration is when you want to generate a flat file list of all your objects and metadata. You just want a report, how many objects are there, and associated details about the objects like creation time, modification time, what type of file it is, right? You want to do all that. Next is access point. Now guys, I'm not covering access point over here deliberately. I'll tell you the reason, because I've already created a really good and appreciated video for this long back. Those who can go to my channel, on my channel, if you see this, hello guys, there's a video, it was created long back, and this is where for the entire 16-17 minutes I've explained in complete detail for how to create the access point, what's the use case of it, and by using this, what you're trying to gain, or what you're trying to achieve as far as data management is concerned. It's a really good concept, and if you can take out time and watch this video, you'll get a better understanding rather than me spending and creating. I haven't created the environment or the scenario here yet, so I'm just trying to skip this for the open masterclass since it is already there in the video. So you can go back and learn more about the access point use case. Next is looking at the advanced security and monitoring part. Let's look at monitoring. As far as advanced security is concerned, we have already spoken about bucket policies, ACL. I told you that AWS S3 supports encryption, right? And block all public access. This is all if you try to focus on and try to understand, this is all part of your security that makes sure that you have a secure bucket to basically place all your data into. Also, one more thing, since we are talking about advanced security, here it talks about IAM analyzer. IAM access analyzer for S3. IAM access analyzer for S3 basically is an automated tool, a component of S3 service that continuously checks for whether the permissions that you're granting are granted within the account. That means to the users in the account. So it wants to make sure that it creates a secure perimeter of the account, that none of the permissions goes beyond account, and that way it just wants to make sure that you're not permitting public to gain access to your resources. If you are making sure that it's the actual thing that you want to do and it's not a configuration mistake. So here it says that bucket with public access, Mahinder, you need to be aware that these are the two buckets that you are sharing to the entire world. This can be risky. If this is what you want to do deliberately, I can select it and I can say archive this finding. That means this is deliberate attempt. That means I'm trying to do this and this is exactly what I'm intending to. Why is IAM Access Analyzer provided? Because you don't have time to get into each and every bucket, clicking on permissions and then trying to read the bucket policy and try to understand and see if block all public access is enabled for all the buckets. You can't do that for, like, God forbid, if you're doing that for like 60, 70 buckets at time. You don't have to. Clicking on IAM Access Analyzer will give you a quick overview that there are buckets which are publicly accessible, and there are buckets that you're sharing not just for this account, people of this account, but also sharing for other AWS accounts. Are you sharing it with other AWS accounts? By defining in the permission that the other account can have access to the objects in the bucket. So this is for the entire world, and this is finding for other AWS accounts other than the one that we are already using here. Now looking at monitoring. So let me show you. For monitoring, you can get into the bucket, and if you click on metrics, since this is created today, we don't have much of, because we don't have much of data as well in this. But if you wait for some time, you will have bucket metrics being populated. For this, let's make use of some other buckets. Here it is. So this I'm using since some time now. Here it shows the total bucket size and number of objects in the bucket. Right? All of these are widgets which are basically coming from CloudWatch. Those who are not aware about, CloudWatch happens to be the service that lets you keep a watch on the entire account, the entire cloud that you're using, right? Makes sense. The name of the service is CloudWatch. Lets you keep a watch on all the resources. So let me show you a bit of a demo for this as well. For CloudWatch, for monitoring of the bucket, we can make use of CloudWatch. As I said, CloudWatch is the name of a service that lets you keep a watch on all the resources of the account. How it does that is by automatically collecting statistical details. Collecting statistical details for all the services. It works for S3, it works for EC2. Considering that we are talking about S3, so if you go and have a look at the metrics, all the services that you've been using, it automatically populates the list of the services. I'm working with S3, so I can click on that. Storage metrics. And now it shows for which bucket do you want to see and what metric do you want to see. Right? Now I can filter out the name of the bucket. Search for this only. Here it is. Number of object. or maybe I'm selecting the total bucket size. Okay, you'll be able to see. And I mean, right now I'm just showing you the metrics. I'm not showing you the graph, but if you go ahead and you want to create your own dashboard for the purposes, you can create a custom dashboard and include that. So dashboards are out of scope as of now for this discussion, but you definitely can. And in all these metrics, let's say I've selected this bucket size. I can, since it is CloudWatch, I can click on alarm and I can say that if my bucket size grows more than 10 GB in size, notify me through mail or through SMS, and it will do that job. Right? You can create an alarm for it since it is metrics that we are talking about. Server access log we have already spoken about. Server access logging. Let's see if server access logging has taken effect. Not yet. This is what we are talking about, server access logging. So let me make a change, and instead of the same bucket, let's place it in a different bucket altogether. So let me do that in Macy. So as then when I try accessing it, maybe it shows up over here. But right now I'm just going to proceed ahead because I can see the time is running out. I'm really sorry about that. We've taken a long time. I mean, these are the points that I wanted to talk about. So guys, last part here, designing for scalability. What are the important points you need to keep in mind for when you are designing and using S3 for scalability purposes? So there are some important points that I want to bring to the screen. Now, first point about designing for scalability is data organization. You need to make sure that your bucket structure, you use a flat structure with minimal number of buckets. What happens is one thing that is seen, because you can create a bucket, people start creating buckets, and for each and everything they keep creating a bucket. Remember, a single bucket can be used for multiple purposes. You can basically use prefixes. So next point is prefix design. You can basically use prefixes. For example, I can use folder, a logical hierarchy. So in a single bucket named mycompany.com, I can create a folder for sales, for marketing, and I can make sure that using access point, none of these team members are stepping toes on each other when they are trying to access the data. Right? Access point can be a good use case for using a single bucket for multiple purposes. Now, as far as scalability is concerned, see, working with key value pair database, you also need to understand that these are NoSQL kind of databases which are used, and NoSQL databases were designed for horizontal scaling, right? Making sure that the data is partitioned across multiple systems. And when partitioning takes place, you definitely have uh, uh, performance bottlenecks, and how you can avoid it is by if I can increase the font. And how you can avoid it is by using a good key distribution. Now, the moment we talk about key, we understand the name of the file is the key. If we have a file, and imagine, I'm not saying that S3 documentation says this, but imagine if you use the same kind of file name, right, for all the data, when it is being distributed and the file is converted into a hash and it keeps into a particular hashed partition, you will find that the performance of your S3 improves. It will be on a better side for when you are trying to upload or download the object. Parallelism can be easily achieved. We've spoken about that. Parallelism can be achieved using multi-part upload, and also because multi-part upload, we have multiple IPs. So right now, when you're trying to upload any object, by default, S3 uses multiple IPs, which makes it a lot faster for you to upload the objects. And you can also make use of transfer acceleration. That's basically your performance optimization as well. Event-driven architecture, we've spoken about S3 event notification, and you can associate that with services like AWS Lambda, SQS, and SNS. We've spoken for performance optimization. I spoke about multi-part upload for uploading and byte range fetching for downloading parallelly, right? This can improve the performance of your upload and download, and also transfer acceleration is going to help in that. As far as cost efficiency is concerned, I spoke about lifecycle policies that can be implemented to change the object from one storage class to another. And finally, when it is not needed, you can also delete the object. So policy-based data management. If you are not sure about your access pattern, make sure that for the object you select intelligent tiering. This will definitely help you reduce the cost. And if you can compress the data and then send it to S3 to store, you are definitely saving money, right? Next, designing for scalability, you also need to be aware about security, making sure that you follow principle of least privilege, and with the help of bucket policies and ACL, you enforce it, right? Making use of server-side encryption and blocking public access to your buckets will make sure that you have a good security implemented for your buckets. As far as reliability and availability of the data is concerned, we have versioning that can be enabled, right? If you by default or by mistake you delete the data and you want it back, versioning can help you. Point in time restores can be easily done using versioning. Then we have for redundancy at regional level, we have cross-region replication that can be enabled. Now, if you have some regulatory compliance, say for example, you have God forbid, I'm not saying, but if in case there happens to be a case in the court of law and there happens to be a file that is an evidence, and you want to make sure that nothing happens to that file shouldn't be deleted in any case, or it shouldn't be changed at all, you can put an object lock onto the file. Let me show you. So if I select this file, I can put an object lock. Now, right now it says object lock is disabled. Reason is object lock can only be enabled. It can only be enabled when you're trying to create a bucket, and while creation of the bucket, you have specified that the bucket supports object lock. If during creation you haven't specified that the bucket supports object locking, you won't be able to use object lock. So hence it is disabled, and you can see after a bucket has been created. To enable, you need to enable the object locking in the bucket, and then you can make use of this feature. Yeah, monitoring and analytics. I spoke about CloudWatch metrics. right? You can enable server access logging, and storage class analysis can be done with the help of CloudWatch to understand the access pattern and maybe to optimize performance as well as cost. As far as automation is concerned, we have event bridge can be used for scheduling for conditional automation. For example, I have a Lambda function that is created to clear the bucket periodically. So the period that we specify, that when and how frequently it is going to be triggered, can be easily scheduled in Amazon Event Bridge. For provisioning of the buckets, you can make use of AWS CloudFormation or Terraform to automate provisioning of the bucket, changes in the bucket configuration. S3 is easily integratable with the other AWS services. You can integrate that. We have services which are again out of scope for right now. Amazon Athena, that could have been spoken about. Amazon Macy for DLP, data loss protection, right? So guys, these are some of the important points that you may want to consider for when you are designing for scalability. And with that, we have completed yeah, I'm sorry guys. Thank you so much for giving the opportunity and attending this course, this open masterclass. Guys, if you have any questions or if you want to suggest some changes for this, I'm definitely looking forward to the comments. And I hope this was helpful for all of you. And yeah, let's see. I'm going to soon announce the next open masterclass, and we'll have a good time here, right? Happy learning. Thank you so much, guys. Bye bye.